So in this video, we're going to show the formation of a dipeptide. All right, so we talked about the amino acids, and hopefully you've learned the 20 amino acids, their one-letter abbreviation, and their three-letter abbreviation. So now let's take two amino acids, right? So all right, here is one, and hopefully you all recognize this as being histidine with the one-letter abbreviation H and its three-letter abbreviation HIS, right? And now let's draw another amino acid. All right, a little distorted, but I'll keep it. Ta-da-da. Alpha, beta, gamma, delta. All right, and hopefully you recognize this amino acid as isoleucine, or I, LE, or I. All right, so we know that amino acids are the building blocks of proteins, right? And when a polypeptide chain is formed, it's really through a condensation reaction between two given amino acids, right? So you have the oxygen from the carboxylic acid group and really the protons from the amino group of an adjacent amino acids. And those two would react to lose a water molecule, right? So it's a condensation reaction. And through that condensation reaction, or the loss of a water molecule, a peptide bond is formed, or what you may know more as an amide bond, right? One example of an amide bond is a peptide bond. So let's draw the product. And remember, oxygen is a poor leaving group, but you could protonate it from the amino group. You'd get a hydroxide, which is a poor leaving group, but you could protonate it once again, which becomes water, which is an excellent leaving group. And then you'd have a carbocation right here, but you'd have the nitrogen with a lone pair of electrons and a negative charge, so it can attack the carbocation, and a water molecule is lost. Okay, so let's draw how a dipeptide would look like. So we're still going to start from the left side, where we have the amino group, right? And we're going to draw histidine and its imidazole ring. But for a second, I'm going to keep it as the alpha carbon, right? So we have a carboxylic acid group. And then we have a new bond that formed. And that new bond was between the carbon of that carboxylic acid group and the nitrogen of the adjacent amino acid. So that's this new bond that formed, right? And then we have the nitrogen, which still has one hydrogen. And then we basically have the alpha carbon. And then we have a carboxylic acid group, right? So if you think about it now, this bond right here is the peptide bond, or the amide bond, right? And somehow these pens eventually stop writing. Okay, so just wanted to keep it a different color. All right, so that's the alpha carbon of histidine, and this is the alpha carbon of isoleucine. And notice how they alternate, all right? So for histidine, hydrogen. And for isoleucine, it's side chain alpha, beta, gamma. Alpha, beta, gamma, delta. And here we go. Alpha, beta, gamma, delta. Alpha, beta, gamma, delta. That's what I thought. I have one extra carbon here. Right. So they'll alternate. So those side chains are actually trans to one another, right? And that particular group right here is what we refer to as the peptide bond, right? We call this a dipeptide because it's composed of 2 amino acids. We call the end, so notice now we only have 1 amino group and 1 carboxylic acid group. We call one end of it the end terminus of the peptide. Right? And we always write a peptide sequence starting from the N terminus going to its C terminus. Right? So what do we call that particular peptide? Do we call it histidine isoleucine? No, we typically actually abbreviate them using either their 3-letter abbreviation or their 1-letter abbreviation. So if it was the 2-letter abbreviation for that particular sequence, it would be histidine dash isoleucine. And I'm not sure that you could see it down here, but it would look like histidine dash isoleucine. Or we can write the sequence as a 1-letter abbreviation. For histidine, it's H. For isoleucine, it's I. Hi. All right. You can actually draw a peptide sequence using your first name or your last name. Try it based on the 1-letter abbreviation of the amino acid. All right, so hopefully this helps you basically identify that a peptide sequence, what we need to recognize is the N terminus, the C terminus of the peptide, and a peptide bond. And when you draw a peptide sequence, always just draw the alpha carbon for the moment being and then go in and fill the side chain. It makes it a lot easier, all right? And then what you need to do is write the name of it. If you're using the 3-letter abbreviation, do use a dash. If you're writing it using the 1-letter abbreviation, ignore the dashes. All right, and we always write the sequence starting from the N terminus going to the C terminus. And if you encounter a longer peptide sequence and you're not sure how many amino acids does it have, find your peptide bonds. In other words, so alpha carbon, an amide bond, and then here's another alpha carbon, and here's an amide bond, and here's another alpha carbon, and I'm just going to end it right here. But here's one peptide bond, here's another peptide bond. 2 peptide bonds mean 3 amino acids, right? I'm going to make them all into alanine. Here's one alanine, here's another alanine, and here's another alanine. So if you were to write the sequence, it would be alanine, 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 or alanine, alanine, and alanine. So however many peptide bonds, you have 1 extra amino acid. That's its N terminus, and that's its C terminus. All right, sideways is fun sometimes. All right, I hope this was useful, and I'll see you guys next time.